Hey, algebra students, in this lesson, we're going to be talking about characteristics of quadratic functions. These are going to be functions that have an x squared term that, when graphed, make a parabola. Now, what we're going to start with is some terminology that we're going to need to know, and then we're going to dive into some practice problems related to quadratic functions. So, first of all, a quadratic function, I don't have a definition here, but I'm just going to restate because we learned in an earlier lesson. A quadratic function is a function that has a squared variable as its highest order variable and nothing in the denominator. So, like x squared plus 3x minus 2. We're used to calling these trinomials because a lot of the trinomials that we've seen so far were quadratic in nature. However, not all trinomials are quadratic. Because remember, we've had some that were like x to the fourth, x to the sixth. Those would not be quadratics. But as long as it's just x squared, then we have a quadratic expression. Now, what makes it a function is we have an equal sign and then a variable on the other side of the function. I'll be showing you what that looks like in just a second. Now, when we graph these, when we graph quadratic functions, we get a shape called a parabola. Okay, a parabola looks like this. It's a curved shape. It starts either at the bottom or at the top, comes to a highest point or a lowest point, and then it turns around and goes back in the direction that it came from. Parabolas have several features that we need to be familiar with. First of all, parabolas have a vertex, the highest or lowest point on a parabola. Notice that because this parabola opens downward, it's going to have a highest point that it reaches, and then either end is going to go downward. This parabola, on the other hand, opens upward. It's going to have a lowest point, and then either side is going to go upward. Now, how can we tell whether a parabola is going to have a high point or a low point? Well, if we look at the x squared term, if the x squared term has a negative coefficient, like this has a negative 1, remember there's an implied 1 in front. This has a negative 1 as a coefficient on the x squared term, the leading coefficient. That means that if it's negative, the parabola opens downward. If it's a positive coefficient for our leading coefficient, the parabola is going to open upward. In this case, it's positive 1, so the parabola is going to open upward. A parabola that opens downward has a maximum. A parabola that opens upward has a minimum. Now, that's going to seem a little bit counterintuitive. What that means is that if you have a negative leading coefficient, you're going to have a maximum. It feels like it should be the opposite, right? And if you have a positive leading coefficient, you have a minimum, but that's just the way it is. Now, um, the highest point or the lowest point is called a minimum or a maximum for a parabola. The minimum of a function is the least possible value. This parabola here is going to have a minimum because it has a low point. Now, I just want to point one other thing out. Notice I'm saying the minimum of a function, not of a parabola. This is a very general thing to talk about. Any function could potentially have a minimum value. We're going to be focused on the minimum of a parabola in this lesson, though, or the maximum of a parabola, the greatest possible value. A parabola that opens downward with a negative leading coefficient is going to have a maximum value that the function can take. Then we're going to talk about the zero of a parabola. Those are the value of x that make the function equal to 0. Another way to think about this, the handiest way to think about this, you look at the graph and you see where it crosses the x axis. Notice that this graph crosses the x axis at -1. That means that -1 is a 0. If I plug in -1, it's going to make this function equal 0. Hey, let's just try that. What's -1 squared? -1 squared is 1, but it's -1 0. So it's -1 plus 2 times -1. 2 times -1 is -2. So -1 plus -2 is -3 plus 3 is 0. But look, this function also has a 0 at 3. So I should be able to plug in 3 for x and get a 0 also. Let's see what happens there. 3 squared is 9. This could be -9 plus 2 times 3 is 6. Negative 9 plus 6 is negative 3. Negative 3 plus 3 is 0. This parabola, a parabola has up to 2 zeros. However, some parabolas don't have any zeros. This one never crosses the x-axis, so it never has a value of 0 no matter what I plug in for x. That means that this one has no zeros, and sometimes some functions can have just 1 0 if it just barely kisses the x-axis as it goes by. In other words, the minimum or the maximum of the parabola is on the x-axis. So this one looks like it has a 0 at negative 2. Let's see what happens if we plug in negative 2. Negative 2 squared is 4. 3 times 4 is 12. Plus, let's see, 12 times negative 2 is negative 24. So 12 plus negative 24 is 12 plus negative 24 is negative 12. Negative 12 plus 12 is 0. Mwah. Looks like we solved that one. All right. And then the axis of symmetry is a line that divides a figure into two mirror image halves. Every parabola has an axis of symmetry that passes through the vertex of the parabola. I can easily calculate the axis of symmetry using this equation. Supposing that I have an equation y equals some coefficient times x squared, so ax squared, plus some coefficient times x, bx, plus c. I'm going to look at those coefficients, okay? I'm going to ignore the c. I don't care what the c is. I'm going to look at the a and the b. And I'm going to write this equation. X equals negative b. I'm just going to plug in whatever this b value is, divided by 2a. Okay? X equals negative b. That's a number, a coefficient number, divided by 2a. A is a number. I'm going to have an actual number. And whatever x equals that's going to be my line for my axis of symmetry. All right, now I can talk about all these definitions all day, but it's not going to actually make sense until we do some practice problems. We're going to do our practice problems next.